Welcome everyone. Today we're going to learn about static electricity. And this is Paul. He works for Electrostatic, the industry leader in anti-static fiber technology. Paul, how does static electricity work? Well, it's an imbalance between negative and positive charges in objects. But what does this mean? You have probably experienced it yourself when you pulled off a woolen sweater and the hairs on your arms stood up. Well, that's electrostatic energy. In practice, this could be bad, like when touching electronic parts or even people. But even without a woolen sweater, there's always a chance static electricity could build up. However, Electrostatic has a practical solution for these problems. Just watch these examples. Paul is inspecting a gas plant. With each step he takes, he becomes more and more charged due to the rubbing of his arms with his clothing. Charged Paul touches a gas tap, and he feels a spark. Paul has to repair a gas leakage. He walks through the gas plant, and with each step he takes, he becomes more and more charged. The charges are coming from his feet and from above, due to the rubbing of his arms with his clothing. Charged Paul approaches the gas pipe, which has a gas leakage, and touches the pipe. Paul is heading over to a production unit. He comes in the proximity of a charged big bag, and the charges are attracted to Paul's clothing by induction. Charged Paul approaches a metal gas pipe, which has a gas leakage, and touches the pipe. Well, Paul, these examples have shown us how static electricity is created. Electrostatic energy builds up in three ways. Through the movement of a person, like the contact and separation of their shoe soles and the ground. Also, through the contact of a person's clothing and their body. And lastly, by induction. For example, when a person comes into the electrical field of a charged object. And what affected the charge your body built up in these last examples? Two factors. One, the resistance of a person to the ground. The higher the resistance, the higher the charge. And two, the atmospheric humidity. The lower the relative humidity, the higher the charge. Paul is inspecting the plant, but this time he's wearing anti-static shoes, in addition to the anti-static workwear. When he walks, the charges created by rubbing his arms against his clothing are immediately grounded. No sparks or explosions occur when he touches a metal gas tap or pipe. Paul is heading over to the production unit, but this time he's wearing anti-static shoes in addition to the anti-static workwear. He comes in the proximity of a charged big bag, and the charges are attracted to Paul's clothing by induction. The charges immediately flow over Paul to the ground. When Paul moves away from the charged big bag, the flow of charges from the big bag to the person stop, and the remaining charges leave Paul and are grounded. Well, Paul, why do we need to be grounded? To prevent charge buildup on a person and their clothing, and to provide static charges on a person or on their clothing a path to ground to prevent shocks or explosions in the future. How can we ground ourselves? In potentially explosive atmospheres, personnel are grounded by wearing anti-static shoes in combination with anti-static garments. We hope Paul demonstrated the advantages of wearing proper protection, and from now on, we hope you'll keep it safe too. As a bonus, we have some specific footage from our lab proving how efficient our product really is. Stay safe, stay grounded.